Hey, hi guys, my name is Raju. Today we'll talk about maximum subarray, which is very famous problem which has been asked in many big companies, fine companies. So let's try to understand that what the problem is statement. So if you see that you have been given a nums array, you need to find the subarray with the largest sum and return its sum. So basically, for an example, if you see that minus 2, 1, minus 3, 4, minus 1, 2, 1, minus 5, and 4, this is given to you. Basically, you have to look at a subarray, and subarray, it means it will be contiguous, right? So it will not be broken. It's not something like I'll choose 1 here and 4 here, and then 2 here, and then we'll try to sum it up. That's not the case. Basically, it is something like contiguous. So let's try to look at that. So here is the problem statement, and if you see here, right, so what basically we are trying to do, that we are trying to say that uh, you know so so in this particular problem, right, if you see that minus 1 and 2, if we're taking only one array, so it will be minus 2, right? If we're taking minus 2 1, so it will become minus 1. That is still not maximum. If we'll take minus 3, so it's becoming something like minus 3. If we're going to add it, so it will become minus 4. So that's actually problem. So that's we don't want this such kind of things, right? Basically we want something like a contiguous which is maximum. So if you look at that in this particular example, in this example we do have a array here which is 4 minus 1 2 1, right? This is the one, 4 minus 1 2 and 1. If we try to add this array, we are going to get finally the longest one, which is basically a maximum result summation is going to return it. So if we'll add 4 plus minus 1 plus 2 plus 1, it is going to give, this will get cancelled, and finally we are going to get 6. If we're trying to add whole array, for example, if we try to add minus 2 plus 1 plus minus 3, right, and then plus 4, finally if we'll add it, we are going to get lesser than 6. So this is the subarray which is kind of going to give the maximum result. We can't take alone we can also take alone 4, but this is not a maximum. But if we'll try to combine this, it will become minus 1. Again if we'll try to combine it, it will become 0. So this is the one which finally we are going to get it, and this is going to actually give the maximum subarray, right? So this is the problem statement. So let's look at that few of another test case. If we'll talk about test case number 1, so we have just only one, so this is going to return the output as 1. If you look at that example number 3, in this example we are going to add all the element 5 plus 4 plus minus 1 plus 7 plus 8, then we are going to get 23, right? If we're taking 5 4, it's 9. This is not maximum. That's we are going to include minus 1, and then again we are trying to add rest of the things. So that's what the problem statement, and let's try to understand from the brute force solution, right? Let's look at that brute force solution, how we are actually going to solve it. If you see that, right, brute force solution, if you think about that, so basically what actually we are doing, we have to take a array. For an example, if I have array like minus 2 1 minus 3 4 minus 1 2 1 minus 5 and 4, in that case what you are doing, let's suppose their index is something like 0 1 2 3 4 5 6 7 8. What basically we are doing, that we are going to pick the first element, right, and we are going to find the combination. Like we are taking first element, and then there will be another loop, inner loop, which will move here this direction, and then again it will take this direction. So I mean, when we are moving this direction, we will find the sum, maximum sum, we'll keep it, that maximum sum, and then again we'll try to add it, then again we'll try to evaluate the maximum sum, whether this is going to be greater or lesser. If it is going to be greater, then in that case we have to be replaced, otherwise it will remain same. Similarly we have to do add this, right, like that, and then again we are going to keep in outer loop, and then again we are going to do for all this rest all the elements, like we are keeping it, then we are starting the inner loop from here, we are just keep adding. Similarly we are going to stand here and then keep adding. So basically if you look at the brute force solution, right, what basically we are doing, we are having an outer loop here, right? So let's try to basically make you understand. Just let me just highlight it, how it is actually happening. If you see that we are having that loop which is going to run from 0 to 1, and then inner loop which is going to be run from I to n, right? And we are just considering that sum equal to 0, and this part, right, this part actually going to add that, like between I to j, like adding the element of sub array basically between I to j, because we have I here, we have j here, and then we have a k, and k is basically going to add the element from I to j, right? Because I am starting from here, if you see that I and till j, right? So k is actually starting from I, and k is and going to be end at j, and that's what you're going to sum it. Once we say that, the summation is basically whatever the maximum, whatever the sum I have considered as of now. If you see that max is, I have taken as the minimum value, so first time definitely it's going to be replaced. We'll update the value, and we'll keep doing with all other things. But the thing is that in this scenario, the complexity will become order of nq, right? Which is definitely going to take lots of time because of order of n, because of this part. Order of n will become because of this part, or order of n again it will take this part. So on so if we calculate the total things, is going to be order of n square, n cube basically here. That's actually too much time consuming. Now let's talk about how we can solve this problem, right? To solve this problem, we do have an algorithm called Kadane's algorithm, right? So Kadane's algorithm will help to basically solve the problem. But before going to Kadane's algorithm, let's try to understand that basically how we are going to calculate minimum element and also summation, because this is the two things I have broken down, and these two things will be actually used to understand it. For an example, if you try to see that, how will you find the min element, right, for a given array? So if the array is something like 101, then 102, 99, 203, right? So what we are doing, that we are taking a variable, we are just going to say that it's a max value, and then we are starting from index number 0 till end of the array, and then we are saying that if minimum, right, whatever I have considered the minimum, if it is actually greater than array at I, obviously first time it is going to be, then we are going to update this minimum. So we are taking the min value because this is the minimum, right? This part will be minimum and this part will be not minimum, this will be maximum, and we are going to compare every time, and finally we are going to get the result. So here in that case result will be 99, right? So that is the way to find the minimum, and this is the way to find the sum, right? To find the sum, we are taking a variable which is having initially 0 value, and we are trying to start from the index number 0 to end, and then we are keep adding the element. So that is the way of finding the summation. Now we'll talk about the Kadane's algorithm, how actually it will optimize the problem statement basically to solve this problem in order of n. So now if you look at that, this is basically a optimized solution. What basically we are doing, we have the input called nums, right? The one which we have discussed, right? The problem we have broken down. So basically we have sum. So we have sum, we are just saying that sum is actually nothing but 0, right? Sum I have taken a 0 here, and then I am saying that there is a variable called answer which I am going to return that it's actually a min value. Now what we are doing, we are starting a loop from 0 and we are going till end of the array. We are just keep adding that, right? So we are just trying to find it out. What we are actually trying to do here, we are saying that we are, let's suppose we are going to add first element, right? And then again we are going to add second element. Similarly, all the element we are keep adding it here. So what actually it's happening here, let's take the simple example again to basically understand on this. So there was an example over here. So example number 1, it was something like -2, and then 1, then it was -3, right? And then 4, -1, 2, and then we have 1, right? And then -5 and 4. This is the given basically example. Let's index it 0, 1, 2, 3, 4, 5, 6, 7, 8. That's all, right? So we have these many. Now what we are actually trying to do here, we are taking that nums of I. We are trying to start from 0th index, this particular index, and we are trying to add it. So in this we are trying to add -2 plus 1 we are doing, right? and then once it is done, so we have an answer like there will be -1. We are trying to check if sum is actually greater than answer, right? So -1 is greater than answer. Yes, because initially answer what I have taken that it's a mean value, and mean value will be -2 to the power 31, right? 32 minus 1 basically, right? That is how we are going to do that. So initially it will be -1, then again we are keep doing that, and then we are checking if it is actually coming as negative. Like finally if you look at that, it's negative. -1 is nothing but negative, right? The sum which we got, then we are resetting the value to 0, right? We are making it 0. Because why we are doing that? Because if I'm adding this particular portion, right, it's actually going to this particular element, it's actually going to decrease our overall result. That's the reason we are just resetting to 0. And then again when we are saying that I plus plus, right, I plus plus will become 1. So if it becomes ones, right, in that case what we are trying to do, that we are trying to again, since sum is now 0, so we are saying that 0 plus nums of I. So nums of I means this is, we are taking this is nums of I is nothing but 1. So 0 plus 1. So we are going to say that 1, right? Because previously answer was what? -1. So I am saying that previously answer was -1. Now it's become 1. So I am checking here if it is less than 0. No, it's not. So that means it is going to add up something, because this is positive number. That's the reason we are not going to discard it, right? Now we will take going to go here -3. If we're trying to go to -3, we are going to add it -3 here, right? So 1 plus -3 will do, so it will become -2. So -2 it's going to have in the answer, right? So I'm not going to update the answer. Basically I'm going to update the answer when whatever current sum we have, right? Current sum, if you look at that, current sum should be greater than answer, but the current sum, it was 1, right? This is the current sum, it was 1, but in that case we are not going to update it, because this condition is not going to be satisfied. In that case we are coming back here and we are saying sum is negative. Yes, sum is in negative as of now, right? So that's the reason we are going to make it 0. So we are discarding it because this is playing a different role. Now we are just reaching here at 4. When we are reaching at 4, so let's try to understand here. When we are reaching 4, right, so I'm saying that 0, since sum is now 0, so sum is been resetted to 0. So it's not answer is 1. So as of now answer we have 1, sum is nothing but now 0, right? So what we are trying to do that, so I'm seeing that 0 plus 4 here. So now sum will become 4. Now I'm saying whether sum, means 4 is greater than answer. 4 is greater than 1. Yes, it is. So I'm saying that answer will get updated. So answer will become sum. So answer is going to become 4 now, right? So now I'm checking, is it negative sum? No, it's not. We are going here. We are saying it's -1. So if -1, it will add up -1 into that. So sum was 4. So 4 plus -1 it will do. So 4 plus -1 will do. It will get 3. Right? So answer will become 3. No, answer will remain 4, because if sum is greater than, right, answer, sum is actually what I have added. So now it's become 3. 3 is greater than 4. No, it's not. It's not going to update it, right? So and also sum is not negative, because current sum what we are looking at 3, it's not negative. We'll add come here. Now when we are here, right, we're saying 2. Let's add 2. So we are adding 2. 3 plus 2. So basically if I am going to add 3 plus 2, this is becoming 5. So it's actually greater than. So current sum 5 is greater than answer. Answer was what? 4. So if it is greater than 4, so in that case we are going to update the answer. So now answer will become what? Answer will become 5 in that case, right? So again we are going to move to next. Obviously like sum is not negative, so we are not going to reset it. And when we are reaching here, so we'll see that 1 is there, right? So 1 we are going to add it. So 5 plus 1, because sum was having what? Sum was 5. Now 5 plus 1, it will do that. It will become 6. So let's update the sum as well. So once the sum is actually 6, right, and it is not negative, then again it will try to move. And if it will move that, it is -5. So -5 you are reaching, right? So from it is making 6 minus 5. So this condition is not going to be satisfied, and answer will remain same 6, right? Answer will remain 6. And then in that case, if you're going to move to 4, so I mean 1 plus 4 if you're doing, then again it is going to be 5. So ultimately 6 is basically greater over here, and 6 is going to be return the answer over here, right? I hope like basically this make you understand. Let me know in the comment section if you have any doubt in understanding that. Basically, if you do dry run, you will understand in details. Do dry run in your own, it will make you more clear. So let's try to look at this one over here, how basically we are trying to solve this problem. So this is the one. So if you look at that, right, what we are doing at line number 2, we have been given a input called nums, and we are saying that initially sum equal to 0, and we are saying answer equal to min value, and we are starting a loop which is starting from 0, and it is going to end of the array, and we are saying that sum equal to sum plus num set I. We are just adding the first element, and we're checking that if sum is actually greater than the answer, right? First time obviously it is, and then it will update it, and we are also checking that if it is actually negative, then we are going to reset it, because sum means why we are resetting back to 0, because in the worst scenario, if nothing is going to be add up, finally it is going to have a sum as a 0. Sum will never be in negative. That's the reason we are just trying to make sum as a 0, right? Then we are moving further, and then finally we'll be able to get the answer which is actually going to have the maximum sum. I hope it actually clarify it, and this actually help you understand solving the problem. So now if we try to run this particular code, so we are saying that for all the test case, it's actually getting accepted. For the test case number this one, second one, and for test case number 3, it's getting accepted. We have lots of the test case when we are going to do final submission, and it is actually going to test it out. Yeah, we can see that here we do have it's actually accepted, and there was a lots of the test case which has been run behind it, right? And then we have this much memory and other information is actually displaying over here, right? So that's all about maximum subarray. This is a really very famous problem. I would just recommend you guys to try your own, do dry run. This will really help you a lot, and try to understand that's what the Kadane's algorithm, because Kadane's algorithm is basically playing a vital role here to basically optimize the solution for this given problem, and it is actually solving in order of n time complexity. That's all guys. Thank you for watching.